I will start to introduce myself. I'm Dieter Wagner from Germany. You see, I have a really very packed vita. So I'm member of several groups and leading several groups all about product line engineering and model-based system engineering. So I have a very long experience in this way. Just some word for MBDA. We are a defense company located in Germany, UK, France, and Italy. So we are international company.
So and I'm Sébastien Dubé. So as mentioned, Martin. So I have some experience in systems engineering. I'm also expert on Capella modeling, MBSE community, and working also as well in product line engineering communities in France, mainly at AFIS and Nicosia. And we prepared this presentation. It's work done since several years now in collaboration with MBDA, and we get the support also from Samaras engineering colleagues.
So this is the agenda, what we want to talk about. So in the first half of the speech, I will take the responsibility, and the second half, when we are going into Capella directly, then Sébastien will take over. During our speech, we will have two polls to ask you some specific questions. So please feel free and contribute to these polls. All right, so let's start. Okay, a little bit background what we are doing in MBDA. So since we are a big company, we are doing every 10 years almost a big, huge improvement program. And the current improvement program, it's called Greater Engineering Transformation, which has these two major goals to reduce the lead time by 50% and reduce the non-recurring costs by also 25%. And so we are launched this improvement program. And one of the pillars of this improvement program is product line engineering. And this is what we are talking about today. Okay, so what is the essence? Why we want to change our way of working? So currently we are doing this engineering to order, which is a traditional way of working since decades in many companies, also in our company. So a customer comes with a product request, and we are developing this product specific to him. But this is, everyone can imagine, a long journey. Our development times are usually 8 to 10 years, so it's not really fast. And of course, it's a very costly way of doing. So to do the time pressure, we are going to the configure to order. So this is product line engineering. So in this case, we are, instead of creating a new product, we are configuring new products out of a kind of building blocks. And therefore, we are expecting here a dramatic reduction of lead time as well of the cost. So this is a small chart of the history of our journey. So we are coming from a pure document-driven development. Then we introduced the general knowledge reuse. We wrote a lot of documentation, hundreds, thousands of pages. Nobody is reading this really. Then the new idea, which is almost 10 years ago, this was the previous improvement program. It was an optimistic reuse based upon clone and own. And clone and own is still the practice in our company, which means there is existing starting models like MBSE models for air defense system, and a new project will take this starting model and involve the model for its own purpose. But the problem, no feedback and nothing else. So this is leads us to the current situation. So we want to get to the configurable reuse building blocks with a lot of governance around. This is what we are introducing currently for MBSE parts only. The next step will be we are going to do this for all development domains, and finally we are have then the entire product line engineering approach, which is an end-to-end approach. Okay, so why product line engineering will help us to reduce our costs? This is a small chart. So if you compare different products A to D, and you sum up all these costs to a total amount, and you see the big square about this cost. So it's really a tremendous amount of money mixed. So if we are doing product line engineering, then you see for the first two projects, we spent the same amount of money plus a little bit. So the plus a little bit is the establishing the product line engineering artifacts and methods and processes. So it will take a little bit more cost and time for the first two projects. But then after the third one, you see you get a dramatic reduction of your cost as well of the lead time due to the reuse of the products or building blocks. And so over time, you will get a reduction of costs more and more once you establish more products of the product line family. Yeah, this is the way how it works. So the in general, we need to understand the customer needs, and of course, one of the new steps is to get the features which are needs to be created for a new product. This leads to a feature catalog, which is, and this is the preliminary work we have to do in the first two programs to create such kind of feature catalog, which is the abstract description of our product family. So the feature catalog includes all building blocks depend upon on the logic. So you see here the example of a missile. So it's a missile product family. We are for the future, it's called Flexis. And so you see this is a modular missile which has several variation in payload, in seeker, in airframe, and so on. And all these variations are in the feature catalog established. So the idea now is to create new combinations of this product by just selecting these specific features out of the feature catalog. And this is the configuration of this product. So the configuration is called bill of feature, and so like bill of material, in this case bill of feature, and this is the configuration of an individual product, and this refers to these variations of the provided product family. And out of this, we can, of course, produce different products, A, B, and C, by just having different configurations. So to get here a little bit more background, so this is nothing really what we have established by ourselves. So lucky-wise, there was a couple of years ago a new standard coming out, the ISO 26580, which is the feature-based product line engineering for software and systems. And this is exactly what we were waiting for, because feature-based development is one of our key philosophies since a couple of years already, but we don't have had any governance around, and here the standard brings us the governance. And you see here the standard describes 3 different pillars: the business organization, the technological organization management, and the technology itself. During the greater engineering transformation, we concentrated to the technology only to get hands on the technique, on processes, methods, and so on. But now we are jumping beginning of next year to the business as well. Here, this is the middle area a little bit more in detail. You see here the feature catalogue on the left right corner, top corner, sorry. This is the description of abstract feature catalogue I have explained before. This is really free of any technology knowledge. It's just a public domain information for this configuration process. So below we have the shared asset superset, which is, you recognize the V. So we are working with the V model as a development cycle. And the V model contains different steps of activities, and each of these activities produce artifacts. And these artifacts are called the 150% artifacts. The important thing is that we are connecting each feature to its corresponding artifacts in the shared asset superset. This is the important thing. So once we want to grab one feature out of the feature catalog, then we have everything connected to it. So this helps us later on to create automatic configurations. So next, we are going now to the configuration. So the configuration of a new product, and you see here in the picture 3 different products, green, red, and blue. And each of these products has its own configuration. And if you take a closer look to the picture, you see some grayed out elements. So this is a kind of indication that this feature are not included in this product. And other products have another combination of this kind of feature. So this is then the input to the real magic in product line engineering, because it comes with an automatic generation mechanism, which reads in the specific configuration with the bill of feature, and extracts out of the engineering artifacts these elements which are belonging to this specific product. And this creates then again a smaller V. So you see a green, red, and blue small v as well. This is generated automatically by the configurator, and this called the instance of a product. Okay, so a little bit what the background is for this. We have different working groups around the world. So a French working group which is focusing on the PLE, where Sébastien is also working with this group. There's then, of course, the International INCOSI working group for model-based PLE. There is also the same working group is working on the new standard, the 26581, which is dealing with the configuration aspects of feature-based product line engineering. And nevertheless, there is a book which describe the product line, so model-based product line engineering as a holistic approach. And I'm a co-author of this book. So if you want to have really a deep dive into model-based product line engineering, then this is the best resource for it. So this is a kind of representation that we have 2 pages. So on one side, we have the product line engineering model based upon the feature catalog. And in the top, you see also a kind of differentiation between different features. So in MBDA, we created a set of specialized features for our feature catalog, which have 2 components: the problem space, including capability, use cases, and constraints, as well as solution space features, which are functional design choices. So these are the main purpose. So this is describing the product line engineering side, and on the other side, this is our end-to-end model-based engineering approach, which includes ELM, so the engineering lifecycle management from IBM, as well. We are using Capella, Rhapsody, SysML, and other development tools. And pure variance is the glue logic between these 2 pages of the interconnectivities. So the feature catalog, here a simple representation again of a feature catalog, just for illustration purpose. You will see this later on in the presentation. So for doing this feature catalog, we need to connect those to the shared asset superset. And we decided to have 2 major variation of these variation points. The first one is the atomic variation point, which is almost a design choice. So you have a design choice between 2 actuator systems. One is low power consumption, the other is high agility. So if you need to have such kind of a choice, for this purpose, we are providing this atomic variation point. The second one is the starting variation point. Why it's called starting variation point? The starting variation point is always located in the top of our development pyramid. So you see this pyramid with the operational layer, functional layer, and structural layer. So this variation point is located or is placed by the system engineer only on the top level, so in the operational architecture. So to avoid a handmade allocation of features, we decided to have a kind of automation. It's called a propagated feature. So you see from the starting yellow variation point, you see automatic generated blue variation points, which indicates in the functional world as well in the structural world which things belongs to this starting feature. So this is a kind of propagation tree, and this is performed for Rhapsody as our second tool as a script, and for Capella we are doing this by automatism, which comes with pure variance along, and this is about our speech as well.
So as we mentioned, as Dieter mentioned, so the MBDA MBSE framework is high level with 3 layers. It's agnostic somehow of the tools or language like SysML or Arcadia modeling language, and we mapped this concept to the Arcadia concepts. So you find again this well-known layers scheme from Arcadia, and so we have exactly the same concepts that presented by Dieter, but propagated into the Arcadia layers following the traceability links that are established directly into the Capella model. So let's maybe jump directly to our example. So we first describe a really simplified, extremely simplified system, which is an actuator to control the direction and the movement. So we can visualize a simplified system architecture from Capella model with a specific functional chain, which is somehow described a fictive feature called de-icing to warm up the surface when we are in high altitude elements. And we will see how these variation points are defined using pure variance and Capella. So first, we describe the atomic variation point. So as mentioned, Dieter, this atomic selects a specific design choice directly targeted on the physical architecture of the simplified actuator system. Here it's related to the technology used for the motor, and this you have the feature catalog described in pure variance, and in Capella you will have a kind of a mapping between the feature catalog and the model elements in Capella. So it's provided by pure variance features. And then this, you can see that the model elements associated with the variation points are directly referred here on the configuration of in pure variance. So then you have a variation point which is propagated. So I illustrate quite quickly the animation here. So where you place the variation point to the capability level, and then it follows the traceability links into the Capella model, and this is described here, automatically computed by the pure variance tool for the Capella layer, thanks to the Arcadia methodology. So this is for the simple variation points. So then we also addressed in the really complex models. We addressed the hierarchical levels between system levels, and so here it's an extraction of the representation done in the Capella website, and we have the possibility to define a feature catalog at the system level, and then a feature catalog describing the subsystems levels. You have basically two approach. One called top-down approach breakdown, which follows the classical way to develop systems. So you have first abstraction level, and then you go down to the new level. For new system, it's quite a common approach, but for existing systems, we used, and we will detail this more, we used what we call the products assembly, where the system level is somehow an integration of existing variants of the existing products. So for this, we just illustrated here quickly this mechanism in pure variants, where you have here the definition of what we called the selection of the product. So it's for variants called variant collections. And then this refers to existing configuration of specific subsystem actuator levels. And to go from the system to the subsystems, it's also possible to couple this with the common well-known approach called system to subsystem transition. So basically, it's this way that is proposed to assemble and to handle the complexity of different systems.
So the final slides are describing what we have achieved during this greater engineering transformation. So we have created several guidelines how to do product line engineering as a concept. Then we have guidelines for MBSE, so specialized for Rhapsody, Capella, and DNG, so those next generation, as well for the factory. Also, we have some illustrations, some sample models created as an international aspect. And we have also created some kind of e-learnings so that people speed up a little bit faster. Yeah, this is one of the last slides. So what is the greater engineering transformation? You see here, this is the digital thread, the green line of the V model, including the production. So this is what we have achieved with greater engineering transformation. And the green underlaid areas is the MBSE part. And the next step, what we are just started, will start next year, is to continue the journey for all the development things. So what, as a conclusion, a model-based product line engineering is the key enabler to provide a strong governance. So this is really the missing piece of what we have missed during the last couple of years, but with the new standard, we have everything in place. So the setup of the PLE organization, processes, methods, and tools is quite straightforward. It's not easy to do because every company has its complex environment and everything needs to fit together. But it's good and handle, so we are under good shape. But here the red one is really the most important thing. We need to have a change in mindset. So an organizational change to enable really the configure to order philosophy in our company. So this is what we need to establish this process of buying change. And nevertheless, the configuration management becomes also a very important point, and therefore we are working with this new standard, the 26581, which describes exactly the configuration management aspects.
Awesome. Thank you very much, Dieter and Sébastien. Did you use RecRPL in addition of pure variants to handle reuse? If yes, how did you mix the both?
We have not yet deployed this completely at MBDA level, but yes, we mixed it also in other contexts. And how I would say that the REC RPL mechanism is somehow the possibility to create a template, something which is reused many times. So basically, the concept that I try to explain with the variant collection will target one specific instance defined in the REC element, and maybe you will have different RECs for different variants of a different product, and which is selected using the variant collection mechanism.
So yeah, next one by Hans Günther. What degree of AI support do you employ?
Dieter, do you want to answer? For the moment, I think not so much, but we intend to use it more in the future.
Yes, so AI will be a part of the next step beyond the business case we are currently was planning to work next year. But AI will help us, of course, to identify the proper bill of feature so that we are having a kind of automation over there. But for development purpose, I think since we are on a very high sensitive and safety related product world, I don't think so that AI really can help us dramatically here.
Thank you. The question is, how would you rate the additional effort required to set up the PLE on systems architecture level as compared to classical development baseline?
It's not an easy to answer question. This is depend upon how your organization is really working. So the classical development baseline usually is if you really go classic, you have just documents. This is then, of course, compared to documents, you have in the model-based product line engineering a lot more effort because you have to do a granular requirement or the granular management of your artifacts. And this leads, of course, to an overhead in this managing of these baselines.
Yeah, and maybe I can add that this overhead also depend on the granularly, the fine grain level you go to the feature level. If you go too much in the technological details, there could be more overhead.
So the automotive industry is struggling with exactly this granularity currently. So a typical car has a configuration space over 10H powered 105 different solutions. And this is coming from this huge variability. So this brings, of course, a tremendous amount of overhead. So this is a bad example, and we don't follow such kind of an example like the automotive industry.
Perfect. Thanks for the answer. So
maybe can we see the result of the polls for the last minutes?
Oh, yeah, okay.
The
wonderful.
team has
maximized them. So this is the result, I think, for the first one.
Yeah, so clone and own is still the way how most people are working. But even 5% already product line engineering organization are very, very interesting. Okay.
Okay.
So a lot of, So
it's a brand new technique. So please take the time and read our book model-based product line engineering, then I guess you see the huge benefit out of this.
Yeah, and we can provide some support as LGM also for you if you need some support.
All right. Thanks a lot for the audience. It was a pleasure to give this speech to you.
Yeah, thank you, Dieter and Sébastien, for this talk. It was really interesting to see a concrete example of product line engineering.